Hi guys, today I'm going to illustrate how to model non-tenured cash flows in three different ways and allocate them to time buckets based on their behavior. While it is easy to allocate tenured cash flows such as bonds and fixed deposits, as these funds have a set maturity date, it is a bit more complex performing this on non-tenured cash flows such as savings, current accounts, and other non-contractual cash flows. Sometimes this can be done arbitrarily on the discretion of the fund or asset and liability manager and just allocating these cash flows randomly. However, most regulators will want to see a basis for the decisions taken in this allocation, and this is why I'm using the behavioral methods. Here I'll be using three variants of behavioral analysis to model these cash flows. They are regression analysis, runoff model, and demographic-based allocation of cash flows. Starting off with the regression analysis, here I have a data array from the 25th of May 2018 to the 31st of December 2020, depicting the saving liabilities of a financial institution. I want to allocate these funds over the various time buckets that I have above, which are the overnight time buckets 2 to 7 days, 8 to 15 days, 16 to 30 days, 1 to 2 months, 2 to 3 months, 3 to 6 months, 6 to 12 months, 1 to 3 years, 3 to 5 years, and above 5 years. We'll be regressing these cash flows over time. And what the regression helps us do is to identify the core portion of deposits, which are the stable funds, from the non-core portion of deposits. That's the portion of the savings deposit that is volatile or that could be withdrawn from customers. And basically what we do once we get the core portion is we allocate the core portion into the above 5 years time bucket, then figure out how we are going to allocate the non-core portion into the other time buckets. The above 5 year, why we are locating the core portion to the above 5 years is because this is a stable portion of funds that we do not expect to move anytime soon, except say maybe there's a run on the bank, which is not a normal everyday event. Starting off our regression, I substitute the dates with numbers. Before I start the regression. Once we have substituted the numbers for our dates, we start the regression proper, and we do that under the data tab of Excel. To use a regression on Excel, you must have already downloaded the data analysis pack. So what we just do is click on the data analysis pack, go to regression, click on OK, and our Y variable or Y range are dependent variables, what we want explained rather, and our X variable is what will do the explanation, which is time, or in this event the substitution, the numbers which you have substituted for time, and we press OK, and here we have it. This is the result of the regression, but we're not using all of that. All we're just interested in is the intercept. Now the intercept is our core variables. Is our core deposit. It shows the portion of deposits that are not going to move regardless of whatever happens, except maybe if there's a run on the bank, of course. And we basically copy that and bring that to our table here. I will put that here. Now that we have brought in our core deposits, we now have to model the remaining non-core deposits into the into our other time buckets. And just a second, let me get our current deposit or the last deposit date. So our last deposit was £7.357 million, and our core deposit is £1.189 million. Our core deposit is roughly 16% of our total deposits as at the 31st of December 2020. And one of the issues with using the regression method for modeling cash flows is that while it lets you know what your core deposits are, it does nothing to tell you what your non-core deposits are. So to rephrase that properly, while we do know that 16.16% of our current deposits is our core deposits, we do not know how to allocate the remaining non-core deposits. And this also leaves us with the problem of how to allocate them. We can do this arbitrarily, or we are left to doing this arbitrarily since there's no scientific method of doing it. And our non-core portion is basically 1 minus our core portion. Now, if I want to be lazy, what I can do in allocating this is just count the number of other time buckets we have and allocate it all evenly. Just to confirm that everything has been allocated. So there we have it. We understand where our core portion is, but because we're allocating this arbitrarily, we are going to assume, or whatever the manager, the fund manager or the ALM manager assumes, is where the other portion of the non-core cash flows are modeled to be in, and this might not be in line with reality. Moving on to the runoff model, we'll be using the same data set that we use for the regression analysis. The runoff model is slightly more complex, but it models cash flow based on the behavior of the cash flows in each time bucket, and it enables us to allocate cash flows scientifically rather than using our subjective judgments. And it relies on a couple of parameters such as minimum value, balance, compound annual growth rate (CAGR), a new minimum balance which will compute, current balance, core balance, non-core balance, and runoff rates. Starting with the minimum balance, we get that just simply by looking for the minimum balance that our data set has had over the time period, and we use the minimum value to just highlight our array, and we get that figure. And then to compute our CAGR, we also need our current balance, which is basically this. Our CAGR is simply our current balance divided by our minimum balance raised to the power of time elapsed. Now 951 days have elapsed from the beginning of our data set, which began in May 25th on 25th of May 2018, to our current day of 31st of December 2020. So we raised that to 365 divided by this. minus 1. So our compound annual growth rate is 220. To get the new minimum balance, it will simply be the original minimum balance we had times 1 plus our growth rate. And there we have our new minimum balance. Now to calculate our core balance, it will now simply be our new minimum balance divided by our current balance, and we have a core balance of 15.44%. And our non-core balance will now then be 1 minus our core balance. The next thing on our agenda is to calculate our runoff rates. This takes a bit of computing, but I'll give us an example of how this is done. So basically we calculate the change between the time periods highlighted in each time bucket. For example, for the overnight period, it will just simply be our current balance minus the previous divided by the previous day's balance minus 1. And then we drag down. I'm not going to drag down to the end, but once we drag down, the next thing we do is we delete the positives there and leave only the negatives. It's because we are more interested in the runoffs, or how the account loses balance. That's why we're deleting the positives and we're left with only the negatives. You can see that it's the same as the overnight time bucket. And then the next thing we do is we find the average of all attritions, of all negative, absolute value of all negative attritions throughout the time period. And we simply drag for all the various time buckets. You'll notice we don't have that for 1 to 3 years and 3 to 5 years because they do not have any our data points do not allow us to calculate the runoff for 1 to 3 years or 3 to 5 years. And then for this above 5 years, we simply bring our core balance here. Now to get the summation of our runoff rates, we just add what we've already calculated. Now that we have computed our runoff rates, the next thing is to compute the actual runoff. And that will be the runoff for that time bucket divided by the total runoff, make it constant, times our current balance times our non-core balance, make both of them constant. And then we go to our core balance, which is 15.44% of our current balance. And as a check to ensure that we have done it's correct, summing up all our time buckets, we see that we have the same exact value as our current balance. Lastly, for the demographic based allocation, we'll be doing things slightly different. If you notice, we've reduced the number of time buckets and the time buckets are larger. This is because we're modeling across age ranges instead of over time. Now, while the runoff and the regression were based on on charting behavioral patterns of our cash flows over time. This is at a point in time modeling of behavior based on the characteristics of individuals or components of that of that fund. Here we're going to assume that each fund here belongs to an individual, and these individuals, maybe for example a pension fund, the liabilities of a pension fund belonging to individuals within that pension fund, and to generate ages of these individuals, we'll do it randomly using the rand number function. For example, let's say our individuals are aged between 21 to 80 years, for example, and we drag down. So we have their ages at this point in time. Hold on, so that it doesn't keep changing, I'll make this constant. And then we arrange these individuals by age. Let me shift this a bit, and we say less than 35 years, basically. Copy this. Look for where individuals here. Second time bucket is, I just want to freeze this so that I'm able to refer to our time buckets. The next age band is 35 to 45. So once we get to 35, yes, so 35 to 45 years. Then we look for individuals 46 to, once they're 46, let's take this from 46 instead. And then start from 51 to 55 years. Basically, we're going to just do this across all age groups. I'll be back in a second. Now that we have allocated all our individuals and their balances into age brackets, the next thing we do is create a pivot table of this age of these individuals based on their age bracket, and we insert a pivot table. Okay. Age bracket vis-a-vis balances. And we copy and take this information to our demography model page. And put them in the different time buckets. And there we have it. Distribution of balances based on the demographic structure of the fund. So there you have it. We've come to the end of today's walkthrough, and we've basically learned how to structure balances using the regression analysis method, the runoff analysis method, and based on demography. Take care and bye for now.